Hi and Assalamualaikum. My name is Nur Anis Natasha binti Muhasan. In this video, I'm going to present about my industrial training journey for 15 weeks.
Background of company. UiTM MTC Hammerl is a collaboration of MTC Engineering Neighborhood and Faculty of Mechanical Engineering, UiTM, to conduct research and development of high-energy material used for any applications. To innovate the nation defense technologies with priority on self-reliance. The products that are produced by Hammerl can be seen every day in a range of products listed below, which are smoke bombs AW2, which is designed to mark a target for aerial attack, indicate wind direction, or create a smoke screen, among other things. And another product is Squib. Squib is an explosive device to produce bullet hit special effects (SFX) in film production. And another product is Rocket. For example, Rocket STEM and Rocket Hybrid.
This is the organization chart of Hammerl. The head of Hammerl is Prof. Madya TS Dr. Zuraida binti Saleh, and the head of MTC Defense is Lieutenant Colonel Tuan Muhammad Joani, and follow the assistant head of Hammerl are the engineers, senior technician, and research assistants. Objective of industrial training is to experience the real application of the material science theories in the workplace. And another objective is to develop skills and technique in a specific profession of respective fields. The scope of training, students can gain beneficial practical knowledge and get viewpoints and fresh ideas about the working technique. And this project focuses on the fabrication of rocket body parts, including fins and nose cone, which is innovate the material of the rocket body parts by using fiberglass instead of 3D printed prototype, which is use the material of the filament winding. Objective of the project to introduce the new superior material used to fabricate rocket body parts instead of 3D printed prototype. And the other one is to analyze the capabilities of fiberglass reinforced epoxy as composite material by using the method of hand layup. The projects that have been done are fabrication of fiberglass rocket nose cone and fabrication of rocket fins. Rocket nose cone by using fiberglass material. So for the first step of the fabrication of rocket nose cone, the board was cut into the size and shape of a nose cone prototype, which is prototype is the 3D printed. After cutting the board, the nose cone is made sure that it fits half of the parting board, and the cap was filled with the clay between the board and nose cone prototype. The wax and PVA release agent were put onto the board and nose cone and dried for a moment. So 4 pieces of the fiberglass cloth for each mold were cut into parts. The first layer of the fiberglass was put on the top of the nose cone prototype and the board, and the epoxy was sprayed carefully. The bubble was removed. The second layer was put and 200 grams of epoxy was sprayed. This step was followed until it reached the 4th layer of fiberglass. Next, the half nose cone was left for 24 hours. And the half mold was taken out from the nose cone from the board, and the adhesive board on the mold was cleaned using the sandpaper. Another half of the nose cone followed the similar method and left it for 24 hours again. The nose cone mold was opened after drilling, and the wax and PVA were put all over the mold. After that, the 4 pieces of fiberglass were put layer by layer according to the mold shape with the epoxy into it and left it for 24 hours. The adhesive fiberglass around the edge of the nose cone mold were trimmed, and the 39-gram mixture of epoxy and fiberglass was put on the edges of the mold. The nose cone was taken out from the mold, and the nose cone was cleaned by using the sandpaper. The epoxy was sprayed on the nose cone by using a brush for the smooth finishing, and the nose cone was done. Fabrication of rocket fin by using fiberglass material. To fabricate the rocket fin by using fiberglass material, we use hand layup method. Layup method is the simplest and oldest open molding method for fabricating composite. At first, dry fibers in the form of woven, knitted, stitched, or bone fabrics are manually placed in the mold, and a brush is used to apply the resin matrix on the reinforcing material. A layup process is a molding process for composite materials in which the final product is obtained by overlapping a specific number of different layers, usually made of continuous polymeric or ceramic fibers and a thermoset polymeric liquid matrix.
The first step of the rocket fin fabrication, firstly the fiberglass clothes were cut into 8 pieces. Then the wax was put onto the board and a piece of plastic was put and the wax put again, and the same goes to the mold. Next, fiberglass cloth was cut for the first layer and a mixture of epoxy. Epoxy A and B was put with a ratio of 150 to 45 that has been stirred earlier. The epoxy mixture was flattened and made sure there was no bubble. This step was repeated until the 8th layer was reached. For the last step, a hydraulic jack machine was used to press the fin for the better results, and the fin was left for 24 hours, and all the specifications of the fins were recorded, including the width of the epoxy, width of the composite material, and the others. So, the conclusion that we get is the good communication skills and leadership skills are required and important to produce the adaptable students equipped with the technical knowledge, skills, and competence skills. So, students are exposed to a real working environment where it is an efficient method in producing an excellent graduate. The real application of the material science theories in the workplace had been experienced by the students themselves, and the skills and techniques gained in a specific profession made the students being well-rounded. The benefits that should be possessed by every Hamrell's employees are credibility, reliability, and intimacy with respect to self-orientation to measure the trustworthiness. Also, the Hamrell had taught us the values of the integrity, zero harm, teamwork, innovation, and performance. Prior to this industrial training program, the author only has the background knowledge of the material science in theory. But at the UiTM MTC Hamrell, the author gets to experience the real application of the theories and how some of it is practiced in solving and researching the R&D problems. Also, the author had realized that R&D is never an easy task, but with the right guidance from the experienced workers, it becomes less difficult. And author do believe that there are still a lot of rooms for improvement, and will make sure that all the time spent in UiTM MTC Hamrell will be valuable for the author, the company, and the university.